Okay, if I remember correctly, we only have one example left from lesson 21, and it was this one. All the other ones we had already done. They were, this is the only one that is an initial value problem. All the other ones were just find a general solution. There were no initial conditions, but I wanted to do one where you have an initial condition. When you have an initial condition and the degree is higher than 2, it's pretty labor intensive, as we will see. This is only degree 3. And the reason is because since it's degree 3, you're going to have 3 unknowns, right? So you're going to have a system that is 3 by 3 system, 3 equations in 3 unknowns. If you had a degree 4 differential equation, then you would have a 4 by 4 system and so on. So the higher the order, the more labor intensive it is. Um, so that's why we're only doing an example of order 3. If you have order 4 and above, that's a little too much. You probably want to use a computer for that. Okay, so let's uh, let's start this one. All right, so we have this initial value problem. We're gonna have to solve it. First, we found a general solution of this problem. So we start by uh, writing down the characteristic equation. I mean, this is a linear differential equation with constant coefficients. So you solve it by figuring out what is the characteristic equation and solving that. So the characteristic equation of this is 4r cubed plus r plus 5 equals 0. And then you're supposed to solve this. Okay, and remember how we solve this. We have to use the rational roots theorem. Use the rational roots theorem to figure out some of the roots of this. And remember, the rational roots theorem tells me that the possible values for r are divisors of 5. I mean, you put plus or minus. Then divisors of 5 over divisors of 4. Divisors of the constant term divided by divisors of the leading coefficient. So though, and then you write here all the possible combinations. So all the possible combinations are going to be on top divisors of 5 are just 1 and 5. And then on bottom you could have the divisors of 4 are 1, 2, 4. So those are all the possible combinations you could have, plus or minus. You could have 1 over 1, 1 over 2, a quarter. You could have 5 halves, negative 5 halves, negative 1 quarter, negative 5, because that would be negative 5 over 1, 5 over 1, and so on. There's a bunch of possibilities there. So these are the numbers that you should try to see if any of them is the solution of this polynomial equation right here. If you try other numbers that are not any of these, you're wasting your time. Now, then you spend some time trying them out, and you can figure out that if you try negative 1, that actually works. So this works because 4 to the negative 1, I mean times negative 1 to the third plus negative 1 plus 5, this is indeed 0. That one works, so that means that is a root. So that means this is a root, which means in turn that r plus 1 is a factor. It is a factor of the polynomial, so it appears in the factorization. Once you know that it is a factor, you're supposed to do long division, or In this case, because this is just a binomial of order 1 with the coefficient of r being 1, you could use also synthetic division. In class, we did long division, so we did two examples, or maybe three, but we use long division. So for now, I just want to use synthetic division because it's good to review that stuff too. All right, so let's do synthetic division. So this is going to be, getting ready for that, I write here the coefficients of the polynomial, remembering to fill in any missing terms with zeros. So you would have 4, you have to put a 0 because the quadratic term is missing, and then 1 and 5. And outside you put -1, which is the root. Okay, then first step, you bring that down, that's a 4. Then you multiply 4 times -1, that's -4, and you write it down here. And then you add down, this is -4. -4 times -1 is +4, so you write it down here. And then you add down, 1 plus 4 is 5. And lastly, 5 times -1 is -5, you write it down here. And then adding down you get 0, which is what we expected because the remainder should have been 0 if this is a factor. So that means that once you divide, you get the factorization. This is 4. The result is 4r squared minus 4 plus 5. So that means then that this thing right here factors as r plus 1 times 4r squared minus 4r plus 5 equals 0. And you don't have to use synthetic division. If you like, if you prefer long division, use that instead. I don't care. But for test purposes, I do want to see something, either synthetic division or long division, okay? So you need to include that work there. Or if you're doing grouping or whatever technique you're using for factoring that, I want to see it. Okay, so equal to 0 because that's what we have. This polynomial equals 0. This polynomial factors as that, so that equals 0. Okay, so then the roots for this are going to be, well, we have r equals -1, which is this part equal to 0, and then this part you set equal to 0 and solve that, and the best way to go for that is to use the quadratic formula. So using the quadratic formula there, you're going to get r equals -b plus, -4, -4, which is +4, plus or minus the square root of b squared, which is 16, minus 4 times a times c, all that over 2a. Okay, and then simplifying, that is 4 plus or minus, this is 16 minus 80, so that is -64, all that over 8. Let's keep simplifying, this is 4 plus or minus 8i, right? Square root of 64 is 8, but square root of -64, that's imaginary, you have to put the I. So I, all that over 8. And then to simplify this further, we need to factor. You can factor out a 4 from the top. Remember, you cannot cancel until you factor. This is 1 plus or minus 2i over 8. And now we can cancel the 8 and the 4. So that gives me 1, and that gives me 2. So then this is 1 plus or minus 2i over 2. And splitting that up, that is 1/2 plus or minus I. So here are all the roots of this polynomial. Okay. Once you have all the roots, then now you can write down the general solution. So the general solution is going to be, well, have that real root and these complex roots. The general solution is going to be y equals, for this one, I get c1 e to the negative t. Remember that? And then for this one, we get c2 e to the 1/2 t. 1/2 t is the same as t half. Cosine of 1t, which is t, and then c3 e to the t halves sine of t. That is the general solution. That is the general solution. Okay, now we have to figure out what is the particular solution using the initial conditions. Okay, so let's continue on another page here. All right, so now let's find what is, we have to figure out what is C1, C2, and C3 using the initial conditions. Okay, this is the annoying part because we have to find the derivative. Okay, we have this initial condition. That means we have to plug in 0 in y. This is y. But then this is y, right? But then we have to plug in 0 in the derivative. And then we have to plug in 0 in the second derivative. So that means of this mess right here, we have to find the derivative. And after we find the derivative, we have to find the derivative again. Okay, that is the annoying part. But let's do it. Okay, so let's find the first derivative. So the first derivative is going to be, the derivative of that part is negative c1 e to the negative t. The derivative of that, that's a product rule right there. So it's going to be the derivative of the first. So the first is just that, the exponential part. So that's going to be 1/2 c2 e to the t over 2, derivative of the first times the second. Now plus the first times the derivative of the second. The derivative of the second, the derivative of cosine is negative sign. So minus c2 e to the t over 2 sine. And now we have to find the derivative of this term, and that's again another product rule. So this is going to be plus the derivative of the first, which is going to be 1/2 c3 e to the t over 2 times the second, plus the first times the derivative of the second. The derivative of the sine is cosine, so it's going to be plus c3 e to the t over 2 cosine. And then we simplify this. I don't even remember how we did this, how we simplified this, but we usually simplify this by collecting the cosines and collecting the sines. So simplifying this, that one is all by itself, but then you collect the cosines together, and then you collect the sines together. So collecting the cosines together, this is 1/2 c2 e to the t over 2 plus c3 e to the t over 2 cosine. And now let's collect the sines together. So this is going to be 1/2 c3 e to the t over 2 minus c2 e to the t over 2 sine. Okay, so all of that is the derivative of y. So it's only a little bit annoying. It was only this much work, and then collecting like terms. So it's not that bad. But then we have to do this again one more time. Now we have to find the second derivative. Okay, now let's see. We have to do the second derivative. So let's just be careful. Now, the derivative of that is c1 e to the negative t plus, now, all that is going to be the first, everything in the parentheses is going to be the first, and then the cosine is the second. Product rule. The derivative of the first times the second plus the first times the derivative of the second. So the derivative of the first, that is, the derivative of this part is just you get another half, so this is going to be a quarter. c2 e to the t over 2. The derivative of that part, you get a half, 1 half, c3 e to the t over 2. So that's the derivative of the first times the second plus the first times the derivative of the second. The derivative of the second is negative sign, so I put a minus in there. Okay, now let's continue. Now do the same thing here. Product rule. The derivative of the first, well, that is, you get a quarter because you get another half from there, so a quarter, c3 e to the t over 2 minus 1 half c2 e to the t over 2 as the derivative of the first times the second plus the first times the derivative of the second. The derivative sign is cosine. Okay, all of that is the second derivative. Now we could simplify that, but actually because I'm not really interested in the second derivative, I'm not going to simplify it. We're gonna be plugging in 0 right away. That's what we care about. The reason I simplified this one is because we were going to take the derivative again of that, and if you have a mess, then that's not going to help. So we needed to simplify it, so to make our lives easier when we take the derivative again. But now we don't have to take the derivative of that. We can just plug in 0 and be done with it. Okay, so now let's plug in 0 in the original, in the first derivative, and in the second derivative. When you plug in 0 in the original, right, in y, you're going to get c1, e to the 0 is 1, so you're going to get c1, cosine of 0 is 1, that is 1, so you're going to get c2 from here, and sine of 0 is 0. So that disappears. So you're going to get c1 plus c2. Now plug in, now use initial conditions. So when we plug in 0 in the first derivative, we get c1 plus c2. Okay, plugging in 0 here, you get c1 plus c2. However, the initial condition says that when you plug in 0 in y, you're supposed to get 2. So that means that c1 plus c2 equals 2. Okay. Now let's plug in 0 in the second derivative. In the first derivative. Plugging in 0 here for t, all of this goes. The sine of 0 is 0, so everything gets killed. Cosine of 0 is 1, that is 1, that is 1, and that is 1. So you end up with negative c1, let's look at that, negative c1 plus a half c2 plus c3 equals What did they tell us that's supposed to be equal to? They told us that's supposed to be equal to 1. So that is 1. And lastly, now you plug in 0 in the second derivative. Everything that has a sign goes. Sign of 0 is 0. All of that disappears. So you want to only end up with C1 and then all of this, which is plus a quarter C2 plus a half C3 minus a half C2 minus C3. Oh, no. Wait a minute. That's a mistake. That you get this one, 1/4 C2 plus 1/2 C3, but then this goes, that goes. What you get, we're supposed to get is this one, plus 1/2 C3 minus C2. Okay, now it's fixed. 1/2 C3 minus C2, and what did they tell us that's supposed to be? When you plug in 0 in the second derivative, you're supposed to get -1. You're supposed to get -1. Okay, and that's our system. That's our system. Okay, we have to solve this. We're going to clean this up in order to solve it. I'm going to write, you can change the order of these equations. I'm gonna write this one at the top. It has so much going on. We're going to simplify it. So this is C1 combining the C4, the C2s. You get a quarter and -1. Those are the like terms. A quarter and -1. That's -3/4 C2, and then plus the C3s. A half and a half is 1. So C3 equals -1. Okay, so that's the last one. I wrote it first. Then the middle one is -C1 plus a half C2 plus C3 equals 1. And lastly, I'm going to copy this one, the first one. C1 plus C2 equals 2. Right, and I left a space here because we normally write, the C1s, the C2s. There's nothing for the C3, so it's just plus 0 C3 in the constants. All right, now let's solve this. I would like to eliminate the C3, so you can multiply, you can subtract these two equations. So that means you can multiply the first equation by -1. Okay, I'm going to multiply the first equation by -1. I'm going to use another color here. I'm going to multiply the first equation, everything, by -1. So multiplied by -1. That's what we're going to do. And when you multiply by -1, that changes, that changes, that changes, and that changes. All right, so now adding equation 1 and 2, what do we get when we add equation 1 and 2? Oops, sorry. Let me organize this. Adding equation 1 and 2, equations 1 and 2, these two, you're going to get negative 2C1 plus 3/4 and 1/2. Well, 1/2 is 2/4, so that's 5/4. C2, the C's disappear, the C3's disappear, and you end up with 2. And then the third equation is C1 plus C2 equals 2. So now that's our system. Now we have two equations in two unknowns. So that's better. We went from three equations in three unknowns to two equations in two unknowns. Okay, now we can eliminate another variable. Let's eliminate C1. So to eliminate C1, multiply by 2. So you're going to multiply by 2 this equation, and then the system is going to become 2C1, so the first one stays the same, and the second one becomes 2C1 plus 2C2 equals 4. And then adding down, you see that's the whole point, these two are the same, add up to 0. Adding down, this is, on the right hand side is going to be 6, but then this is, let's see, 2 is 8 quarters, 8 and 5 is 13. So 13 quarters C2. And now multiply by 4. 13 C2 equals 24. And divide by 13. So C2 equals 24 over 13. Aha. See, we found one of the constants. To find the other constant, now let's find C1. Plug it in there. C1. Then C1 is going to be 2 minus C2, moving the C2 to the other side. And then we already know now what C2 is, so this is 2 minus 24 over 13. 2 is 26 over 13. So 26 minus 24 is 2 over 13. Aha, so now that is C2. And lastly, C3. We could use any of the equations, the one that looks the easiest. Let's see, which one is the one that looks the easiest? This one looks easier. So moving the C1 and the C2 to the other side, we can get that C3 equals 1 minus, I'm using the second one. C3 equals 1 minus, plus C1 minus 1 half C2. Okay, move that and that to the other side. 1 plus C1 minus 1 half C2. Okay, so now let's plug in. So this is 1 plus C1. C1 is 2 over 13 minus 1 half C2. C2 is 24 over 13. So this is 1 plus 2 over 13. The 2's cancel to get minus 12 over 13, which is 13 over 13 plus 2 over 13 minus 12 over 13, which simplifies to 13 plus 2 is 15. 15 minus 12 is 3. So that is C3, and now we found all the constants, and we're finally done. Ooh, that was a lot of work. Okay, so y is going to be y is this. But now we know C1, C2, and C3. So C1 is 2 over 13. That's the C1 right there. E to the negative t plus C2. C2, where is C2? C2, C2. No, plus C2, where is C2? C2 is, oh, there it is, that one. 24 over 13, 24 over 13, e to the t halves, cosine of t, plus C3, and C3 is 3 over 13, e to the t halves, sine of t. And that is the final answer. All right.